The study that seems difficult today will make your future tomorrow because you don't have any extra talent or big capital. Wow. Let that reality check sink in for just a second. I mean, it's a bit of tough love straight from our source material, but honestly, it perfectly sets the stage for what we're doing here. Because let's be real, for most students, the time, speed, and distance chapter, it just feels like this impossible mountain to climb. But mastering this math isn't just about scraping by on a test, it's literally about securing your future, especially when you don't have a massive safety net to fall back on. So, welcome to this explainer. I am absolutely thrilled to be your guide today. Our mission is super clear. We are going to conquer this incredibly intimidating chapter once and for all. And no, we are not going to do it the hard, agonizing, traditional way. Instead, we're going to extract and master the absolute best shortcuts and foundational concepts laid out by Gagan Pratap sir. Seriously, by the time we wrap up, you'll be completely bypassing those long equations and solving really complex exam problems in just seconds. It's going to be a game changer. Okay, here's our roadmap for today. We'll start with the foundation of speed and time, master unit conversions, and unlock the 3 golden ratio rules. Then, we'll cap it all off with 2 massive shortcuts, the total time and time difference formulas. Stick with me and you'll get a complete, foolproof toolkit for your exams. All right, let's jump straight into section 1, the foundation of speed and time, the absolute basics. You know, we've got to start at the bottom of the mountain before we can sprint to the peak, right? Now, what's actually kind of fascinating here is just how simple the core definition of speed is. It's simply the distance you travel in exactly 1 unit of time, whether that's 1 hour, 1 minute, or 1 second. Think about it like this. Imagine you're driving a big delivery truck. You hit the road, and over the course of 8 hours, you cover 240 kilometers. So, to find your speed, you just take that 240-kilometer distance and divide it by the 8 hours of time. The result? 30 kilometers per hour. Meaning, in every single 1-hour chunk, you are moving exactly 30 kilometers. That is your absolute baseline. Speed equals distance divided by time. Moving right along to section 2, mastering unit conversions. Now, this might sound a little basic, but pay close attention because this is exactly where so many people throw away easy points during a high-pressure exam. So the absolute must-have skill here is knowing how to seamlessly switch back and forth between kilometers per hour and meters per second. The cheat code? It's the fraction 5/18. If you have kilometers per hour and you need meters per second, you just multiply by 5/18. And if you need to go the other way around, just flip it. Multiply by 18/5. Let's look at a really cool real-world example from our source material, the Vande Bharat train. It travels at a massive speed of 162 kilometers per hour. If an exam suddenly asks for that speed in meters per second, you don't need to panic. You just take that 162 and multiply it by 5/18. Well, 18 goes into 162 exactly 9 times, and 9 times 5 is 45. Boom! Instantly you know that train is moving at a blistering 45 meters every single second. Okay, section 3, the 3 golden ratio rules. This is where we officially shift from basic math to unlocking some serious proportional superpowers that will let you skip messy calculations altogether. Practically every complex time, speed, and distance problem you'll face is built on one of these 3 logical rules. Rule 1. If the distance is fixed, speed and time are inversely proportional, meaning drive faster, you take less time. Rule 2. If the time is fixed, distance is directly proportional to speed. So if you and a friend travel for exactly 2 hours, whoever drives faster is going to cover more ground. Makes sense, right? And rule 3. If speed is fixed, distance is directly proportional to time. If you drive at a constant, steady speed, the longer you drive, the farther you go. Let's actually see Rule 1 in action. Imagine a journey from Delhi to Patna. The distance between them? Completely fixed. Person A travels at 80 kilometers per hour. Person B travels at 100 kilometers per hour. If we simplify those speeds, the ratio of their speed is 4:5. Now, because the distance is identical for both travelers, the time they take will be the exact inverse of their speed ratio. It literally just perfectly flips. Therefore, their time ratio is 5:4. I'm telling you, if you can grasp this simple inverse flip, you've just eliminated half the algebra from your exams. Up next is section 4, the total time formula. Think of this as the round-trip cheat code. We are officially entering the boss battles now, starting with our first one-step formula for those frustrating round-trip journeys. Okay, you have definitely seen this classic, super time-consuming exam scenario. A boy walks to school at a rather sluggish 4.5 kilometers per hour and then eagerly returns home at 7.5 kilometers per hour. The total time for the entire round trip is 144 minutes. The question asks, what is the one-way distance? Traditionally, you'd have to set up an equation with an x for distance, divide by the first speed, add it to x divided by the second speed, convert your minutes to hours, and then somehow try to isolate x. It is agonizing and it takes way too much time. But check out this ultimate shortcut. To find the distance directly, you just multiply speed 1 by speed 2, divide that by the sum of speed 1 and speed 2, and then multiply the whole thing by the total time. Think of it as product of the speeds over the sum of the speeds times the total time. That's it. It completely bypasses all that tedious algebraic work. The only thing you got to remember is that because your speeds are in kilometers per hour, your total time absolutely must be converted into hours. So let's see how this builds into a totally lightning-fast solution. We just plug our numbers right into the formula. Multiply the speeds, 4.5 times 7.5. Divide by their sum, well, 4.5 plus 7.5 is exactly 12. Then, multiply by the time in hours. Since 144 minutes divided by 60 gives us 12 over 5 hours, we use that. And look how perfectly this works out. The 12 in the time fraction cancels beautifully with the 12 in our speed sum, so we're just left with 33.75 divided by 5, which equals exactly 6.75 kilometers. What usually takes minutes of frantic scribbling is solved in seconds with a clean, rapid payoff. Isn't that awesome? And finally, Section 5, the time difference formula. We are tackling the most notorious exam scenario of them all, the dreaded early and late arrival traps. Here is the tricky scenario that causes so much panic. Tanya walks to the station at 6 kilometers per hour and misses her train by 2 minutes, so she's late. But if she speeds up and walks at 8 kilometers per hour, she arrives 3 minutes before the train even gets there. She's early. We need to find the total distance to the station. Finding the time difference here is where students usually just freeze up, because there's no total time given, only a gap between two hypothetical scenarios. Let's just break the strategy down step by step. Step 1 is simply finding that crucial time difference. If she's 2 minutes late on one end and 3 minutes early on the other, the total gap, or the difference between those two journeys, is 5 minutes. Step 2 is applying our modified cheat code. Notice the big difference in this formula. Because we are working with a time difference, we subtract the speeds in the denominator instead of adding them. So the formula is distance equals the product of the speeds, divided by the difference between the speeds, multiplied by the change in time. All right, let's execute this and get our final victory. Multiply the speeds. 6 times 8 is 48. Divide by the difference between the speeds, 8 minus 6 is 2. So 48 divided by 2 gives us 24. Now, we multiply by the time difference in hours. 5 minutes is 5 over 60, which simplifies down to 1 over 12. Finally, 24 multiplied by 1 over 12 gives us a clean, absolutely perfect 2 kilometers for Tanya's journey. Instant, flawless math, no sweat at all. Wow, okay, we have covered the foundation, the ratio rules, and the ultimate formulas for total time and time differences. You now possess the exact logic and the shortcuts needed to absolutely conquer these exam problems. So I'll leave you with this one question. Are you ready to bypass the long, frustrating equations and apply these exact cheat codes to your next mock test? The tools are in your hands right now. Go out there, practice them, and secure your future. You've got this.